this video I'm going to go over some stoichiometric calculations. So this involves the moles, mass and MR of compounds when they react. So MR is the relative atomic mass of an element, and you can find them on the periodic tables. It's the number on top. The number on the bottom is the proton number, which identifies the element. So if you do an example, we have sodium hydroxide plus hydrochloric acid gives you sodium chloride and water. So given 100 grams of sodium hydroxide, how much hydrochloric acid is needed for the reaction? So we're going to assume that you need it to balance, as in you need the exact amount of hydrochloric acid. So if we make a table, we have moles, mass, MR and ratio. So we're given 100 grams of sodium hydroxide, so 100, and we need to calculate how much HCl is needed for the reaction. We can calculate the MRs by the periodic table. So the MR of sodium is 23, the MR of oxygen is 16, and the MR of hydrogen is 1. So if we add them all together, we get MR of 40. We do the same for hydrochloric acid, 36.5. The ratio, this is the stoichiometric ratio. So if we look at the coefficients before sodium hydroxide and hydrochloric acid, they're both the same, as in it's 1 to 1. So the ratio is 1 to 1. And now we need to work out the number of moles. So as given by this equation, moles equals mass over MR. So moles equals mass over MR. So mass divided by MR is 2.5. Because the ratio is 1 to 1, we need 2.5 moles of sodium hydroxide, we need 2.5 moles of hydrochloric acid. If we rearrange this equation, we can calculate the mass of hydrochloric acid. So if we do that using the numbers we have, 2.5 multiplied by 36.5, that gives us 91.25 grams of hydrochloric acid. Now hydrochloric acid is usually given as an aqueous solution, so you could convert that to milliliters according to the density. So if we do another example, we have calcium hydroxide, this is nitric acid, calcium nitrate and water. 1.5 kilograms of calcium nitrate were formed following the above reaction. Assuming there is excess calcium hydroxide, how much nitric acid was required for the reaction? So we're given that 1.5 kilograms of this product was formed, and we assume there's an excess of calcium hydroxide, so this is the limiting factor. This determines how much of the products are formed. So if we draw out our table, we have nitric acid, and then we have calcium nitrate, we've got moles, mass, MR, and the ratio. So in the question we're told we were given 1.5 kilograms of calcium nitrate, so it's 1,500 grams, assuming excess of calcium nitrate, so we're going to work with this one. The ratios are 2 to 1, because we look at the stoichiometric coefficients. the MRs we can calculate from the periodic table. So the MR of hydrogen is 1, MR of nitrogen is 14, MR of 3 times oxygen, so oxygen is 16, so the MR is 63, and we calculate the MR of calcium nitrate, so MR of calcium is 40.1 plus 2 times, because we have this small 2 here, nitrogen plus 3 times oxygen, which is 16. And that gives us 164.1. Then we use the equation up here, so moles equals mass over MR to calculate moles for calcium nitrate. So mass over MR, so 9.14 moles. Because we have a ratio of 2 to 1, we multiply this value by 2. 18.28 moles. We can rearrange this equation to calculate mass. So we have 18.28 multiplied by 63. So we needed 1,151.74 grams of nitric acid to form 1.5 kilograms of calcium nitrate. And that's it.